This video is entitled Mechanics Overview 1. Write the usual variable and equation for the following energies. Gravitational potential energy near the Earth, m times g times h. You probably used that in a first-year physics class. We use capital U for potential energy. Gravitational potential energy universal or absolute is another way that is said sometimes. And here it is. Negative capital G m1 m2 divided by r. Quite possibly you didn't meet that in a first-year physics class, but we're going to run into it here. Elastic potential energy in a spring, you may have seen this one, 1/2 kx squared. Sometimes you'll see a delta x there, but it's more commonly written in AP Physics as just an x instead of a delta x. And kinetic energy, hopefully you've seen that one before, 1/2 mv squared. So these are equations that relate to what we're going to be talking about this year, and in both mechanics and electricity and magnetism for at least some of these. Energy, you want to make sure you know that energy is a scalar. It's not a vector quantity. This next part is huge. It will come into play several times. The negative derivative of a potential energy U with respect to position x equals the force associated with that type of potential energy. If we were to write out two general equations that demonstrate what we're saying here in English, it would be this. The negative derivative of a potential energy with respect to x. The negative derivative of a potential energy with respect to x equals the force associated with that type of potential energy. So there's one equation that statement reflects. And the other one is the opposite of taking a derivative is taking an integral. So another way that we could express this same essential idea is we could say that the change in potential energy is equal to the force integrated from a position of x1 to a position of x2. Now, we're not going to explain those here in this video, but they will come up as this course rolls on.